IBL is about light, not backdrop. After all, it is IBL and not IBB. This scene is lit exclusively by IBL. The render time is 1 minute and 17 seconds. The pizza and cutlery and the bread are from Pizzeria Italia by McLean. The candle is by David Brennan. The flowers are some Gassania from Lisa's Botanicals, and the vase is from Das. I do not remember the details. The Utah teapot is a classic, and the mirror ball is a Bryce sphere. Again, this scene is exclusively lit by IBL, but somehow it looks unfinished. Since the advent of shadow capturing techniques, mixing objects with an HRI backdrop became a new playground in Bryce. This video is not about shadow capture. This has been covered in videos already, and there are products by David that deal in depth with that technique. Bryce is in the adulthood, but it has not yet fully matured. There are still a couple of features that are missing, particularly as far as the backdrop is concerned, and we have to resort to workarounds. We will work with the panorama as HRI for light and backdrop. A few words about the color. This panorama has the right color, but if we are in this room, we will perceive it rather like this. The fluorescent lamp is actually slightly green, and the bulbs are yellow-red. Here and here. The colors are too blue, as seen with the light bulb here. Nevertheless, they look more natural. The camera was at the height of an average person standing on the floor and put in the middle of the table. The main light comes from the bulb here, which is at 78 degrees elevation, that is 12 degrees off the zenith. The fluorescent lamp is higher up and contributes about half of the light. The other lights also contribute, but less than 10%. We will start with spatial resolution of the HRI used as backdrop. How large must the backdrop be to render sharp? It depends on the FOV, the field of view, of the Bryce camera and the size of the final render. The size of the render is obvious. A 400 pixel wide render does not need such a large backdrop panorama than a 2000 pixel wide one. FOV might be a bit trickier to understand. First, FOV, field of view, in Bryce is not AOF or angle of view, and it depends on the scale set. In the following examples, the camera FOV is set to 90 degrees at scale 100. 90 degrees, scale 100. And this corresponds to a horizontal angle of view of 72 degrees, or a lens with a focal length of 30 millimeters. 72 degrees is a fifth of a full circle of 360 degrees. The width of the panorama in the spherical projection needs to be at least 5 times wider than the width of the final render. The HRI used here has a width of 8260 pixels, and the render is 1000 pixels wide. 8260 divided by 5 is 1652, and we have about 160% of the pixels needed, which is good. However, if we look carefully, we notice that on the left and right sides it appears to be less sharp than in the center part. There are slight distortions, and if we look closely at the flowers to the right, this becomes more obvious. This picture rendered in 2 minutes. A bit of blurriness comes from the stitching of the individual photographs in the HRI. Then we do not exactly know how Bryce treats the HRI loaded. It stands to reason that it also introduces a bit of distortions that show as a slight blur. I suspect that we would need at least twice as many pixels as are rendered to get a full sharp backdrop. In our case, the spherical HRI should be at least 5 times 1000 pixels, which are 10,000 pixels wide. Now Bryce is still a 32-bit application and can normally only handle 2 gigabytes of memory. Though our 10,000 times 5,000 pixel spherical HRI panorama would only need 0.6 gigabytes of memory once loaded and tone mapped. However, the HRI is compressed and decompressing is done in memory. Tone mapping is done in memory as well. And this asks for a lot of memory until the HRI is loaded and tone mapped. And by the way, saving a scene with an HRI is also very memory intensive because the compression of the HRI and the scene is done in memory. This is the process monitor, which is a little bit better than the task manager from Windows because it shows memory usage for Bryce only. Bryce has just been started and it uses about 38 megabytes. Now I'm going to load that scene with a 8260 times 4130 pixel HRI, and we see how the memory is going up. It is reading HRI data now. I'm at 1.5 gigabytes. It is still loading. See, the processor is also working, so it is loaded. This is loading the HRI and this is tone mapping the HRI, which took a long time. And now we are back at about 380 megabytes. The scene doesn't need more, but it needed 1.5 gigabytes just to load. Now I'm going to save this scene. File, save as, or just XX. Yes, I want to replace it and bring this up. Now it is saving the scene and is using now 1.4 gigabytes just to save the scene. And it takes a while. If you are on a 32-bit machine with 2 gigabytes of memory, you will not be able to load this scene because your operating system may already need 600 to 700 megabytes of available memory, and the remaining 1.3 to 1.4 gigabytes will just not suffice. So we have finished. We are back at about 380 megabytes for this scene. The file from this 1.5 gigabyte saving is only around 120 megabytes. So never believe the size of the source file from your scene because this is a compressed file. I could use such a large HRI and measure the memory use because my computer sports 8 gigabytes of memory and I made Bryce large address aware. With this trick, Bryce can use up to about 3.3 gigabytes until it runs out of memory. But this is not the rule, so we have to find ways to work with a smaller HRI as backdrop. Using DOF, depth of field, and a smaller, more blurred HRI is one of the possibilities we will now investigate. The HRI used before had an uncompressed size of 410 megabytes, and the one we will use now has an uncompressed size of 62 megabytes. Its diameter as a probe is 2560 pixels. I will now load this scene and watch the process monitor what it's doing. He is already toe mapping here. Okay, it's been done. The maximum it needed is below 400 megabytes. Currently it is using 170 megabytes. Now I'm going to save this scene. Save as, it's again XX, never mind. Yes, you replace it and see it is going up to almost 400 megabytes to save. It has saved and it's coming down and it's using 180 megabytes. And the scene loads and saves much swifter as well. So using a smaller HDRI is a help in conserving memory. Here is the scene rendered with the smaller HDRI, and we see that things here are quite blurred, but the flowers are quite sharp. If we zoom in on the vase with the flowers, we can see that this cannot be right because the curtains are quite fuzzy while the vase is very sharp. So what we need to do now, since we have no high resolution HDRI loaded, we need to blur these objects to blend into the fuzziness of the backdrop. This has been done here. This scene renders in 28 minutes and 31 seconds. I used quality 512. I selected everything here except the light here and the flowers here. With this selection, I went to the render options and set premium depth of field set to current selection, which is 248. I set the lens radius to 0.09. Here we have again moved the camera and we can see that the vase with the flowers are blurred. I only used 16 rays per pixel, so you can see some noise here, but only because we have it so near. In the normal render you don't notice. The lens radius has its photographic equivalent in the f-stop or diaphragm setting. We would like to have the f-stop numbers instead of the rather arbitrary dimensionless number like 0.09. The higher the lens radius is set, the less the depth of field will be. This means the narrower the range depicted well focused. The HDRI backdrop can also be given background DOF, but it has to be set to 0. We have already a blurred backdrop and we want to make the vase as much blurred that it matches the fuzzy backdrop. The scene, as I said, was rendered with quality 512 and 16 rays per pixel. What we did here was trading memory for render time. What else can we do to get a sharp backdrop without wasting too much of memory? We can load a high-resolution HDRI into an empty scene, tone map it and export it from Bryce as a 24-bit map, BMP or TIFF in the spherical projection. Then quit Bryce. Just show you, this is just a low-resolution HDRI, but you can tone map it, export as image, as a bitmap, 24 bits per pixel, and in the spherical projection. Because it will be mapped on the inside of a sphere, the picture will have to be flipped horizontally, make a mirrored copy of it. This is our exported tone-mapped HRI from Bryce. We have to flip it, just mirror horizontal, and then we can apply a filter like a sharpening filter and then save this one. So we have a high resolution, low dynamic range picture that is flipped or mirrored. We can now map this picture onto a sphere picture. That is our LDRI we've created. It is mapped on the sphere. You have to switch off all shadow casting options, cast shadows, receive shadows and self shadows. Don't need those, and do use parametric mapping. The sphere has to be placed in the world center. I put it to a size of 1024, and you have to know that the parametric mapping offsets the picture on the sphere by 90 degrees clockwise. We have set it to Y0 because the HRI yaw is set to 270 degrees, which is 90 degrees counterclockwise. So this matches the parametric mapped picture on the sphere. They are aligned. We do not always have such a nice arrangement, and the sphere has to be rotated. It is therefore a good idea to load a low or medium resolution HRI so the sphere can be aligned with the HRI backdrop. We've done this here. The sphere with the mirror pictures applied on the sphere of 1024 Bryce units, and there is no match at all. The picture is much wider than the HRI. It appears as if the camera FOV would have almost 180 degrees. What's going on? This is the HRI part, and here is the part of the sphere. We have twice the journal. This one is sharper, so it must be from the sphere, and this one is from the HRI. The HRI backdrop is at infinite distance, whatever infinite means. The sphere with the picture must be larger. The largest it can get is 1,024,000 Bryce units. So I can add 2 zeros and 2 zeros and 2 zeros. This is the maximum. If I give a 0 more, it doesn't work. So this is the render with the HRI backdrop and the sphere with a size of 1,024,000 Bryce units. These pictures are almost correctly aligned. There is a bit of blurriness on this side, and certainly if you watch here the edge of the newspaper, this part is from the HRI and this part is from the sphere. As far as the light is concerned, the HRI and the picture on the sphere are aligned. The sphere, by the way, has 75% transparency, so that we can see what's going on between the picture on the sphere and the HRI backdrop. The HRI can now be exchanged by a very low resolution one. HRI and sphere are aligned as far as the light is concerned. The size of the HRI doesn't matter anymore. In fact, we can use a specular map and get yet another advantage. Here, the HRI is a specular map. It has only 800 pixels diameter. It is not used as a backdrop. It only is here for the light. And what is this radial doing here? It lights up the backdrop sphere. It is just a simple radial with diffuse at 7, and it has no fall-off. This comes in handy because we can change the size of the sphere as the backdrop, and we get always the same light, and we only have included the background. It doesn't even cast shadows, it just lights up the backdrop. And if we go back here, we can see what happens. The backdrop gets darker. The HRI used needs only just 6 megabytes of RAM. The picture on the sphere is 8260 times 4130 pixel panorama and needs 34 megabytes. In total, lights and backdrop take up 40 megabytes. That's all. When measured with the process monitor, then the scene needs 267 megabytes, and to save it 475 megabytes are used. This is a bit more than the 400 megabytes for the medium resolution HRI, but we have a well-focused backdrop. Render time is quite high. This scene needed 15 minutes and 10 seconds, but we've used quality 512. Since we use a specular map for lightening the scene, the light sources are more diffuse and we can reduce the quality and still have no noticeable banding. The HRI is not used as a backdrop. There is no banding, even though this scene has been rendered with a quality of 64 only. Each step of quality increase doubles the render time. Back from 512 to 64, this is 8-fold, because 512 to 256 is twice, 256 to 128 is twice, and 128 to 64 is twice again. So 2 multiplied by 2 multiplied by 2 equals 8. There is no need to use DOF if the backdrop image on the sphere is of adequate resolution. This scene, which is quite sharp, renders in 2 minutes and 9 seconds. And here we have again zoomed in on the vase with the flowers. And okay, it does not completely match here, but again we are quite close. And since in the normal picture these flowers and the vase are quite far away, we don't notice the difference. By the way, this scene rendered in 35 seconds. Now, what happens if the specular convolved HRI is used as a backdrop to some extent? Here we added a bit of the backdrop as tone mapped, and the sphere has 25% of transparency. So a little bit or a fourth of the HDRI backdrop, which is blurred, is mixed into the picture. The scene rendered in 2 minutes and 3 seconds. The colors are less saturated, but if we use the non-tone mapped HDRI and render, we get more saturation, which is quite obvious in this render that took 2 minutes and 6 seconds. The HRI is not tone mapped anymore, so we have more saturation. We can control with the transparency of the sphere also the amount of background color that bleed into the scene. It often happens that a tone-mapped HRI looks a bit low contrast and low saturation. There are almost 50 different tone mappers I know and have experimented with. The one we finally decided to incorporate into Bryce can be used fully automatic with the right initial settings. This tone mapper produces very photorealistic images from an HRI in most of the cases. Nevertheless, sometimes a backdrop could do with a bit more contrast and color saturation. Then you can use the colors to bleed through the sphere with the backdrop picture. Though the HRI is very much blurred, the color hue matches if the transparency of the sphere is set diligently. Letting a part of the known tone-mapped HRI illuminate the backdrop sphere is a neat idea if you need more contrast and color saturation. What can we do if the saturation is already too high without the HDRI lighting up the backdrop image? We have a saturation control in the IBL lab, but it only controls the saturation of the light produced by the HDRI, not the backdrop. Well, if an image on a sphere is used as backdrop, that image can be desaturated in a graphics application. By the way, we have set the saturation to 0 here, so we don't have any colors in the light created by the HDRI, which would have to be compensated for infinite parallel light that is used to create the shadows. If we use the HDRI itself as a backdrop, and it is overly saturated even when tone mapped, we can use something like a neutral density filter. This is again the HDRI with a diameter of 2560 pixels as backdrop. The scene renders in 2 minutes and 16 seconds. I'm using only quality 64. The HDRI is tone mapped, used as the backdrop. This is the same render, but the HDRI is not tone mapped, and it does look a little bit exaggerated. However, we will use this overly saturated backdrop to see what we can do to reduce this high saturation. We create a sphere that surrounds the scene. 1024 Bryce units are enough. As for the material, we use a medium gray, and we will play with the diffusion control, the transparency control, and in the IBL lab with intensity. These are our 3 controls we can use to adjust the saturation. Again, the HDRI has not been tone mapped, but it is already less saturated than the picture before. We have diffuse a gray. We use 50% diffusion and 75% transparency. The intensity of the HDRI has been reduced to 5. Here we have again made some changes. We have the diffusion now at 100, transparency at 50% and intensity lowered to 4. It is less saturated. 100% diffusion, 75% transparency, and on the IBL we have reduced intensity to 4. By the way, the scene renders in 2.5 minutes. Again, less saturation because we changed again. Diffusion and transparency are both at 100 and intensity was again lowered now to 2.5. We have 100% diffusion, 100% transparency. So there's a lot of light that is coming in from the specular map of the HDRI, which is not tone mapped. And so we had to set the intensity lower to match the overall light. And finally, we have yet another method. Though it looks a little bit hazy, but it is even more desaturated, and this scene renders in 1.5 minutes. We have set the sky color to gray. There is no sphere anymore. We have removed it. But we have set HDRI blend with sky and use sky color. And sky color is gray. And we have the HDRI transparent at 60%, so there is only 40% of HDRI and 60% of gray sky color, which creates this render. Now, to make this still less saturated, we could always tone map the HDRI and we have it even more desaturated. We can go the other way around. We start with a monochrome backdrop on a sphere, an LDRI backdrop, and color it with the HRI, which is rendered as backdrop. So I have here the HRI we have used so far, and I made it monochrome. I have toe mapped it linear, which means that the whole dynamic range has been pressed into the range that can be displayed. Nothing special. And we render this. The sphere has now this LDRI mapped parametric, is 100% diffusion and 25% transparency, and of course no shadow casting as we had that before. No cast shadows, no receive shadows, no self shadows. We don't need that. We have the radial light which lights this backdrop and set diffuse to 5 and still no fall off, and it doesn't cast shadows. It's just to light this backdrop, which is actually monochrome. And as a HRI we still use the specular map and don't use it toe mapped. The intensity has been set to 5, and this is the result we get from this. It is a very low saturated render, which completed in 2 minutes and 6 seconds with quality 64. Here the same setup with some changes. As we can see, we have more saturation. The HRI is still monochrome. We still have this one, but we have set transparency to 50%. The radial is still at 5. The HRI is still the specular map and the same intensity. So it's just changing the transparency of the sphere, the radial and HRI intensity, or the intensity of the backdrop. We can change the coloration of the monochrome picture we have in the background. Again, another variation, still a little bit more color. The transparency of the sphere is now again reduced to 25%. Diffuse of the radial light is reduced from 5 to 4. Intensity has been doubled to 10. So we have a lot of light from the HRI coming through the partly transparent sphere, and this gives us even more color here. The resulting picture seems to me has a little bit of a dreamy quality to it, and this is because the HRI in the backdrop that is giving the color to this render is a specular map and is not a fully sharp HRI. For the following, I do not ask you to like what you see. I ask you to think out of the box. Bryce gives the artist freedom and is not limited to photorealistic renders. The HRI was subjected to a diagonal Sobel convolving filter. The way I set up the filter, it enhances lines and inverts them. Dark lines get bright without inverting the light. Light is still the light, but the dark lines are bright lines. So it's partly inverted and partly it is not. Then the result was made monochrome. Apart from the changes made for the LDRI, the setup is the same as for the examples before, and there is a lot of noise in the resulting LDRI, as can be seen here. This is one of the disadvantages of such a filter. This is the render that came out. So we can see here we have bright lines instead of dark lines, and on the newspaper, the white is black and the black is white. However, the curtains seem right, the tables seem right. Very noisy indeed. We have diffuse for the radial light reduced to 2. For the background sphere, we have changed this LDRI. It looks very, very noisy here. It's not that noisy, but nevertheless it is noisy. And we have transparency at 25%, as before, diffusion at 100. So nothing changed very much indeed. And in the backdrop, we still have that specular map with an intensity of 10, giving us the color. And this results in this render. Not natural, but rather different. The scene renders in 5 minutes and 28 seconds. This is a bit darker, but generally it looks the same as the previous one. We have diffuse reduced to 1. The background sphere has 50% transparency, and the intensity of the backdrop has been reduced to half at what it was before, to 5. And we have these results. This should show you that we have 3 parameters we can change to make it look different. Now this is very far out, very saturated colors. You wouldn't believe I have the HRI in the backdrop tone mapped. There is a small difference. We still have the same LDRI mapped around the sphere with a transparency of 25%. We have changed the HRI. We use a tone mapped light probe with only 1280 pixels diameter, but it is not a specular map anymore. The most important difference is the radial. It is set to -7 diffuse, so it actually sucks off the light from the sphere and makes it very high contrast. It also enhances the saturation of the tone mapped HRI. So you're not requested to like this result. Just think of the possibilities. You could use just about any filter to change the LDRI on the sphere. This scene renders in 5 minutes and 14 seconds with quality 64. The long render time is, of course, because there's a lot of anti-aliasing with all this noise in here. This could be a cel-shaded picture if there were not so much details and noise. But from the enhanced lines we have here, the dark lines, and the very saturated colors, we get in the direction of a contour enhanced lines sort of render. To wrap up what we have discussed in this video, using DOF for the objects in the scene if the HRI backdrop is not sharp enough. Export a high-resolution HRI as tone-mapped spherical LDRI panorama. Use this on a huge sphere and replace the HRI with a low-resolution one to save memory. Adjust the color saturation of the HRI backdrop using a sphere as neutral density filter or the sky color. Use a monochrome high-resolution LDRI on a huge sphere, make it partly transparent and light it with a radial, then color it using the HRI as backdrop. And most importantly, think out of the box. Hopefully, these tips will give you even more fun when using Bryce IBL.